Okay, these are for college algebra support, section 9.1. So I'm gonna go to my screen so we can start doing some notes. All right, so first one, they're giving me a function, k of x equals x plus 13. They want me to find each of the following: k of 0, k of negative 11, k of negative 15, k of 18, and then k of b plus 17. So basically, this is 5 problems, 1, 2, 3, 4, 5. I'm going to find each of these function values given this function. So for k of 0, we take that function and put a 0 in for the x. So we get 0 plus 13. And then 0 plus 13 is 13. So k of 0, 13. K of negative 11, I'm going to put a negative 11 in for that x. So I get negative 11 plus 13. So see, this number is telling you what you put into the function for every x. And then you figure out what negative 11 and 13 is, and that is positive 2. So notice the left side is just symbolism telling you what we put in for these x's, okay? So you do nothing with it, you just work that right side once you plug these numbers in for those x's. So k of negative 15, I want to put negative 15 in for x. And then I still got a plus 13, see? So it's still an x plus 13. All right, so now I got a negative and a positive. Subtract 15 minus 13 is 2. Larger number is negative, so the answer is negative 2. All right, k of 18. I put an 18 in for the x, so I get 18 plus 13. All right, so now 18 plus 13 is what, 31? Final answer. Now I meant to show y'all here, this one had unlike signs, and when you add unlike signs, you subtract the numbers. So 13 minus 11 was 2, larger number was positive, so the answer was positive. Here you had unlike signs, so 15 minus 13 was 2, but the larger number was negative, so the answer was negative. And then when you add like signs, they always keep the sign of the two numbers. Now this is going to be tricky. K of b plus 17. So they want me to put a b plus 17 in for the x. So that gives you b plus 17 plus 13 is still at the end. So you replace the x and you still got that plus 13. Now on this one, the only thing you can do is add the like terms. So since that b is the only b, you bring it down. And then you add 17 and 30, so those are your like terms. And 17 and 30 give me, 17 and 13 give me 30. So your final answer would be b plus 30, okay? So they're just wanting to see if you add like terms right in that section. All right, so this problem's sort of the same. They give me f of x equals 2x squared minus 4x. So that's my function. And I'm finding f of 0, f of a negative 1, and then f of a 2. All right, so let's find f of 0 first. F of 0 wants me to put a 0 in for these two x's. So I got 2 times 0 squared minus 4 times 0. So you had two x's, and since we're putting a 0 in for the x's, you got two zeros in there now. So the first thing I'll do is exponent. So bring down that 2. 0 squared, that's 0 times 0, which is 0. And then I'm just going to bring everything down. Now you can do more steps than I do at once. I'm just trying to show y'all how I would do it, follow an order of operations. Now you got two things to multiply, so I'm going to multiply that one and multiply that one. So 2 times 0 is 0, minus 4 times 0 is 0, and 0 minus 0 is 0. Next we do f of negative 1. That's going to be 2 times negative 1 squared minus 4 times negative 1. So once again, I'll do the exponent first. So bring down that 2. -1 squared is -1 times -1, which is +1, minus 4 times -1. All right, so now I'm going to multiply these two and multiply those two. So 2 times 1 is 2. That's like a -4. -4 times a -1 is a +4. And then 2 plus 4 is 6. All right, then what was my last one? F of 2. So f of 2 will equal 2 times 2 squared minus 4 times the 2. So let me get a better pen. All righty. So here we go. Do the exponent first. So I'm going to bring down that 2. 2 squared is 2 times 2, which is 4. And then minus my 4 times 2. So now I'm going to multiply that. So 2 times 4 is 8. Minus 4 times 2 is a minus 8. And then 8 minus 8 is 0. So, you know, that's the trick. Just put these numbers in for the x's, simplify that, and then move on. All right, 3 wants me to practice a little bit of foiling. So they're giving me 5c plus 1/3 squared. So you got to write this twice. 5c plus 1/3 times 5c plus 1/3. All right, so I'm going to move that down a little bit so I can make sure to get you all this problem. So you're going to FOIL. So 5 times 5c is 25c squared. So both these have exponents of 1, and I just added 1 plus 1 and made that a 2. Now I'm going to take the 5c times the 1/3. So y'all, if you got 5 times 1/3, put a 1 under the 5 and multiply straight across. So you get a 5 on top and a 3 on bottom. So 5c times 1/3 will be 5/3 c. Okay, because I got 5/3 from the numbers. Now I do the 1/3 times the 5c. Well, that's going to give me the same thing. It's going to give me a 5/3 c. Okay, 5 over 1 times 1/3 is the same thing. Now the trick is that 1/3 times that 1/3. So when you multiply 1/3 times 1/3, 1 times 1 is 1, 3 times 3 is 9. So that gives me plus a 1 over 9. Now the only other thing you can do is add those like terms. So remember, 5/3, whoops, I got 5/3 c plus 5/3 c. So no matter what, that's going to end in a c. And remember, when you add fractions with a common denominator, the common denominator goes on the bottom, and then 5 plus 5 is 10. So when you add the 5/3 c to 5/3 c, we get a 10/3 c. So my final answer will be 25c squared plus my 10/3 c plus my 1/9 at the end. Okay, so the whole trick on that is, remember, multiplying, you multiply straight across. Adding, they have a common denominator, and then you just add the top. All right, so that's a little bit of foiling practice, and I think I got more of those. All right, so let me pull back up. All right, so there's number 4, which is a minus 4p squared. So we're just wanting you to get used to, when you see parentheses like this with an exponent, you write that ever how many times that exponent says. So I got a minus 4p. I would write that twice, okay? And then FOIL. So exponents can be 1s on everything that don't have an exponent, okay? So watch this. A times a is a squared, because 1 plus 1 is 2. A times negative 4p is a negative 4AP. So all I did was put the letters in alphabetical order. So the A and P can't multiply by each other, so you just put them in order, okay? Now you got a negative 4p times A. That's going to be a negative 4AP. So I just put them in alphabetical order again. And 4 P's and A's don't multiply together, so you just put them in order how they look. Now I got a negative 4P times a negative 4P. So a negative times negative is a positive. So remember, keep up with these signs when you're multiplying everything, okay? All right, 4 times 4 is 16. P times P is a P squared. All right, now the last thing is add like terms. So bring down to A squared. Negative 4AP and another negative 4AP is a negative 8AP. So you can't change the variables when you're adding and subtracting, okay? So I just remember a negative 4 plus a negative 4 is a negative 8. And then bring down your 16P squared. Okay? All right, then number 5, they gave me a really nice one. 4B squared minus 4P squared, all of that squared. So once again, I got stuff in the parentheses being squared, so I got to write the stuff in the parentheses twice. So 4B squared minus 4P squared. All right, wrote that twice, and once again, we're going to FOIL. So the 4B squared times 4B squared, 4 times 4 is 16. B squared times B squared is a B to the 4th. I added 2 plus 2 to get 4. Now, 4B squared times a negative 4P squared is a negative. 4 times 4 is 16. B squared, P squared. So since they weren't the same letters that I was multiplying, they had to stay the same. Okay, I just put them in order. Now, go notice in the middle, negative 4P squared times the 4B squared is a negative 16. B squared, P squared. So see, I'm just multiplying the numbers really and then bringing down the variables. Now the last one is a negative 4P squared times a negative 4P squared. That's going to be a positive 16P. Well, P, where am I at? P squared and P squared give me P to the 4th because 2 plus 2 is 4. All right, then once again, like terms in the middle. So I bring down to 16B4 negative 16 B squared P squared minus 16 more B squared P squared is a negative 32 B squared P squared. And then at the end, bring down your positive 16 P to the 4th. So I know these are big, ugly answers, but y'all, these variables, you got to distribute them and FOIL and then add like terms, and you're still left with what we call trinomials because they have 3 parts. All right, so number 6, they wanted to start working on complex fractions. A complex fraction is a fraction inside of another fraction, okay? So watch this. I got 2 plus 1 divided by 3 all over 4 minus 7 divided by 8. So I'll tell you what I do to these. It's all about least common denominators. So 2 ways you can do it. You can find a common denominator on top, add them together, find a common denominator on the bottom, and do that work. So then you have a 1 fraction over 1 fraction. Then you can flip them and turn that into multiplication, which turns into a little easier process. So watch what I'm going to do. I'm going to put a 1 under the 2 and a 1 under the 4. I'm going to find a least common denominator on the top, and I'll find a least common denominator on the bottom. So on the top, you have a 1 and a 3. That least common denominator will be a 3. On the bottom, you got a 1 and an 8. That least common denominator will be a 8. So let's change the top one. So it's got a 1 on the bottom. So to turn that bottom into a 3, I would multiply the top and the bottom by a 3. This one's already got it, so we're good. So watch what we do. 2 times 3 is 6. Over 1 times 3 is 3. Plus bring down to 1/3. On the bottom, we said the common denominator was 8. Well, this one already has an 8. So I'm going to change this one by multiplying the bottom by 8 and the top by 8. So 4 times 8 is 32 over 1 times 8, which is 8, minus 7 over 8. All right, so now my fractions on top have a common denominator and on bottom have a common denominator. So the top, I'm going to add the 6/3 plus the 1/3. So the thirds will stay the same on the bottom because that's your common denominator. And then 6 plus 1 is 7 on the top. Take that fraction, and on the bottom, you got two fractions with a common denominator of 8. And on the top, 32 minus 7 is 25. Now, to finish this problem, we don't like to divide fractions, so we take the 7/3, change this division into multiplication, and then we flip the bottom fraction. If we flip the bottom fraction, we get an 8 over 25. Now, y'all, we're going to multiply and be done. Now, you can reduce before you multiply, but since the 7 don't reduce with that 3 and 25, the 8 don't have no factors that are reduced with the 3 and the 25. Once you multiply straight across, you're done. So 7 times 8 is 56 all over 3 times 25, which is 75. Now, I'm going to show you that if you had 2 plus 1/3 on top and then 4 minus 7/8 on the bottom, I'm going to do this on the calculator. So the trick on this is to put the top and bottom in fractions. So watch this. I'm going to do a parenthesis, which is above the 8. 2 plus 1 divided by 3, close parentheses. That's going to be divided by the bottom, put that in parentheses, 4 minus 7 divided by 8. Close, oops. Yeah, that's it, right? 4 minus 7 divided by 8. So I got my fraction in. I'm going to hit enter. It gives me a decimal, but you hit math and enter twice, and I get what? A 56 over 75, which is my final answer. Okay? All right, y'all, so let's move on. My number 7, so let me change page. And they're going to do more of these little complex fractions, okay? This one has 3/4 plus 2/3 all over 4/9 minus 1/3. So if you did this one on the calculator, make sure you put parentheses around the top and parentheses around the bottom. It'll give you a decimal, so then you're going to turn that decimal into a fraction, okay? So let me do mine by hand. So I'm going to find the least common denominator on top and bottom. On top, 4 and 3, the smallest number they have is a 12 that they go into. And then on the bottom, you got a 9 and 3. That least common denominator will be the 9. Since 3 is a factor of 9, 9 automatically becomes the common denominator. All right, so let's see. This one needs a 12 on the bottom, so I would multiply that 4 by 3, which means I multiply that 3 by 3. So the first fraction becomes a 9 over 12. Now the second fraction, to turn this 3 into a 12, I multiply by 4. So I do that on the top, and that gives me 8, and then 3 times 4 is 12. So the top has its common denominator. Now the bottom needed a 9, so the 4 over 9 already has 1. Minus, to turn the 3 into a 9, you multiply by 3, which means I multiply the top by 3. So y'all, that gives me what? A 3 over 9. So now I'm going to add my top, subtract my bottom. So on top, that's going to be over a 12, and then 9 plus 8 is 17. The bottom, that'll be over a 9, and 4 minus 3 is 1. So really, common denominators, turn them into one fraction. Now that I got one fraction over one fraction, I'm going to take the top, 17 over 12, change from division to multiplication, and then flip the second fraction so that 1/9 becomes a 9 over 1. Now, 17 cannot reduce with a 12 or a 1, but a 9 can reduce with a 12. So both of them have a 3 in them. So the 9, if you take out a 3, becomes a 3. The 12, if you divide that by 3, becomes a 4. So notice nothing else reduces. So on top, 17 times 3 is 51. On the bottom, 4 times 1 is 4. Now, leave the answer as a improper fraction. You don't have to try to divide and make that into a mixed number, okay? All righty, so 7 could have been done on the calculator. I would have done parentheses, 3 divided by 4, plus 2 divided by 3, close parentheses, divided by parentheses, 4 divided by 9, minus 1 divided by 3, close parentheses, hit enter. But remember, I don't want a decimal. I'm going to hit math and enter twice to turn that into a fraction, and I get my 51 over 4. All right, number 8, same thing. I got an x squared over a y to the 5th being divided by x4 over y to the 3rd. So I'm happy because this is already one fraction. The bottom is already one fraction. So since I got an x2 over y5 and an x4 over y3, I'm going to take the top fraction and write in. Turn that division into multiplication, and then flip the bottom fraction so that I get a y to the 3rd over x to the 4th. Alrighty, so you can simplify this before you multiply, but I'm just going to multiply straight across and get us x2, y3 on top. Then I'm going to put the bottom in order. The y5 times x4 is an x4 y5. Now I'm going to simplify this because you got x's over x's and y's over y's. So what you do on this, write my fraction bar, you take the larger exponent and subtract the smaller exponent from here. So since this exponent 4 is the largest, the x is going to stay in the bottom, and then you do 4 minus 2, which is 2. Then on this side, you got a 3 and a 5. The 5 is the larger exponent in the bottom, so the y is going to stay in the bottom, and then you go 5 minus 3 is 2. Since both the variables are bigger in the bottom and ended up in the bottom, and we got rid of the top now becomes a 1. So y'all watch this. The proper way, 2 minus 4 is -2, but you got to put the x back on the bottom to make the exponent positive. So instead of doing 5 steps to get this answer, always compare the letters. You got the x's here. And I said, well, the biggest exponent was in the bottom, so I kept the x in the bottom. And then I said 4 minus 2 was 2. That's all you're doing is subtracting them once you get them down there and be done, okay? All right, so we're trying to hit you with a lot of rules, right? All right, so check this out. Number 9 is a tricky one. I got 4a squared minus b squared all over ab. That's all over 2a minus b all over a b. So notice, I only got one fraction on top. Although it's got 2 parts on the top, you only got one bottom. So this is one fraction over one fraction. So I'm going to turn this into multiplication. So I'm going to take the top fraction and leave it the same. Change that division into multiplication and then flip the bottom fraction so that I get a b over 2a minus b. So what you really want to do on this problem, since you got these binomials, which are 2-part terms, you want to try to factor these. Now I will say this one does not factor, but this one here will factor. These are what we call perfect squares. So you make 2 set of parentheses when you got perfect squares. you take the square root of the 4a squared and put in the front of each of these. So the square root of 4 is 2, so both of them get a 2. And then the square root of a squared is an a, so they both get an a. Now, since that's negative, you make one of these positive and one of these negative. That's how you get your unlike signs. And then the square root of b would be a b and a b. So when you factor perfect squares, they end up in conjugate pairs, okay? All right, I had an AB on the bottom. Over here, I had a B over 2A minus B. So the 2A minus B can cancel with this 2A minus B because a binomial can cancel with a binomial. This single B, since this is a single term, this B can cancel with this B. So they cancel, making a bunch of ones. So let's see what's left on top. All that's left on top is the 2A plus B. And notice, I didn't need parentheses because that was the only thing left up there, okay? And then I canceled that B, but I still have a A. Now remember, I cannot cancel these A's because this is a binomial, a 2A plus B. It would only cancel with another 2A plus B. So that's as far as you can go on number 9. So hopefully this is all bringing back memories, right? All right, y'all, number 10 is another one. I got a 1 over y plus 3 all over 1 over y minus 5. So I'm going to make the 3 look like a fraction and the 5 look like a fraction. All righty, so I'm going to tell you the truth. The easiest way to do this one, since I got variables in the denominator, and these ones both had a 1, is to multiply everything in here by its least common denominator, which would be the y. Okay? So I'm going to show you a different way to do these. Instead of trying to add these fractions on top and bottom, I'm going to show you how to eliminate these fractions altogether. So I got a least common denominator on bottom. All that's down there is a y and a 1. So I got a 1y for my LCD. So now I'm going to take this whole, watch what I'm going to do. I'm going to take all these fractions and write them real quick. And I'm going to multiply all 4 of these fractions by the y. So see? And the reason I'm doing this, because multiplication distributes over addition and subtraction. And what you do to the top of a fraction, you do to the bottom of a fraction when it comes to multiplying, okay? But watch this. Those y's canceled out. And all that's left is the 1. Over here, well, there's nothing on bottom but a 1. So what you do is you multiply the 3 times y and make that a 3y. On the bottom, you do the same thing. These y's cancel. So what's left is a 1 minus. Only thing on bottom is 1, so you multiply the 5 times y and get a 5y. And that is the final answer, because the only way to cancel the 1 plus 3y is with another 1 plus 3y, okay? So when you get these binomials, it's tricky to try to cancel them, okay? All right, same thing. R minus 1 over r all over 1 plus 1 over r. So since I got the variables on the bottom, I'm going to do that one like I did this one. I'm going to put 1s under those r's. And the LCD is 1 in r, which is a 1r. All right, so let me write these again. So I wrote this again because I'm going to multiply everybody by that r. But what you're noticing is, if you didn't have an r on the bottom, it don't cancel and you basically multiply it. Right here it was a 1 on bottom, so r times r is a r squared minus, those r's cancel, making a 1. Then on bottom, r times r is r squared plus, these r's cancel, leaving a 1. Now I would tell you, you could try to simplify this because the top is perfect squares. The top would actually factor into a r plus 1 in an r minus 1, since it's being subtracted, and the square root of r squared is r's, square root of 1 would be 1's. But y'all, since this bottom is being added, you cannot factor a r squared plus a 1. Okay, that will not factor. So since the bottom don't factor, I don't have to worry about factoring that top, and that would be my final answer. So it's pretty quick when you knock out them denominators, right? All right, 12 gets back into doing some more foiling, but now they're going to foil radicals. So a square root of 2 minus the square root of 10 times square root of 2 plus square root of 10. So inside can multiply by inside when it comes to radicals, and if you got numbers in front of the radicals, they can only multiply by other numbers in front of the radicals. So I'm going to keep everything under the radical when I multiply. Square root of 2 times square root of 2 is the square root of 4. 2 times 2 is 4. Square root of 2 times the square root of 10 is the square root of 20. 2 times 10 is 20. On the inside, negative square root of 10 times square root of 2 is a negative square root of 20. So watch signs on these. And then you got a negative square root of 10 times a positive square root of 10. That's a negative square root of 100. 10 times 10, right? Now, if you notice, those cancel. A square root of 20 and a negative square root of 20, they cancel in the middle. So let's see what's left. I got a square root of 4, which is 2. And then at the end, you got minus the square root of 100, which is 10. Okay, so once I got them all multiplied, at this point, if they don't cancel, I simplify them. So square root of 4 was 2, square root of 100 was 10, and then 2 minus 10 is a negative 8. Okay. All right, 13. Let me see what I got on 13. Okay, this one's going to be different. So 6 plus 4 square root of 2 times 6 minus 4 square root of 2. So these conjugate pairs, notice the radicals canceled in the middle and everything went away as far as radicals. And this one will do the same thing because this is conjugates. Okay, when you multiply conjugates of radicals, the radicals all disappear in the long run. Now watch this. That 6 not under a radical. That 6 is not under a radical. So 6 times 6 is 36. Now I got a 6 times a negative 4 square root of 2. That's going to be a negative. The 6 can only multiply by the 4 because it's outside, and it can only multiply by the outside number. So 6 times 4 is 24 square root of 2. The square root of 2 stayed the same because there was nothing under a radical on this side, okay? Now watch this. 4 square root of 2 times 6, positive times positive is positive. The 4 can multiply by the 6 because it's outside, and then the square root of 2 stays the same because there's not a radical here. And then finally, that positive 4 square root of 2 times that negative 4 square root of 2 is going to be a negative. The 4 on the outside times the 4 on the outside is 16. Square root of 2 times 2 is 4. So this time, since you had a radical times a radical, you multiplied them together, and I kept a number under the radical for that step, okay? So notice, those cancel in the middle. So I'm going to bring down my 36. Those in the middle cancel, negative 24, positive 24, square root of 2's are gone. That negative 16 comes down, and we're going to multiply that by the square root of 4, which is 2. So before you can do any multiplying or any adding, you got to do that radical first. And the square root of 4 was a 2. Now I'll bring down to 36 minus, multiply before you subtract. 16 times 2 is 32. And y'all look at that. Final answer, 36 minus 32 is 4. So notice, conjugate pairs of radicals, you end up with numbers, no radicals, okay? All right, now the last two I do, they won't be conjugates, so these radicals will stick around on these, okay? So 2 plus the square root of 3 squared. So remember, since we got stuff in parentheses squared, we got to write it twice. All right, so let's go. 2 can multiply by 2 because they're both outside, and 2 times 2 is 4. 2 times a positive square root of 3 is a positive 2 square root of 3. Since the 2's outside, it can't multiply by the 3, so you put them together. Same thing in the middle. Square root of 3 here times 2 is another 2 square root of 3. I just put my numbers first and then my radicals. Now here I got a square root of 3 times the square root of 3. That'll be a positive square root of. Inside that 3 times 3 is 9. Now be careful, these don't cancel, okay? So I'll bring down to 4, because these are both positive. So when you add radicals, you add the numbers in front and the radical stays the same. So if you got 2 square root of 3's and you add 2 more square root of 3's, that gives you 4 square root of 3's. Oh, and guess what? I can do that. Square root of 9 is 3. All right, so I got everything brought down, right? Now, the reason I can add these together and do this at the same time is because they were separated by pluses and stuff, and they weren't affecting each other yet. But if you look at this answer, you can see that I can now add that 4 plus 3 and make that a 7 plus 4 square root of 3's. So numbers can add to numbers, but these numbers cannot add to that radicals. Square root of 3 only adds to other square root of 3's, okay? So I hope you're seeing how I'm keeping outside numbers outside and the inside numbers inside, and how they really can't multiply times each other, okay? All right, so another one like that, 6 plus square root of 3 squared. So write that twice. And then once again, FOIL. Here we go. 6 times 6, they're both outside, so they multiply and make a 36. Now you notice I didn't take the square root of that 4 over here like I did that 9 because the 4 was not under a radical, okay? 36 is not under radical, so I'm not square rooting that. All right, 6 times square root of 3 is a positive 6 square root of 3. Square root of 3 times 6 is a 6 square root of 3. Remember, outside numbers cannot multiply by inside numbers. Now, square root of 3 times square root of 3, those are both underneath, so that becomes a square root of 3 times 3 is 9. So what will we do? Once again, we add like terms, and we're going to take the square root of 9 and turn it into a number. So bring down that 36. 6 square root of 3's plus 6 square root of 3's gives me a positive 12 square root of 3's. So when you're adding, you cannot change the way radicals look, okay? Now, what's the square root of 9? That is a positive 3. So once again, I took the square root of 9, but not the 36 because the 36 is not under a radical. And y'all look at that one more time. I got like terms, those numbers. So that 36 plus 3 give me 39 plus my 12 square root of 3's. All right, y'all, so that is your 9.1 support for college algebra. And the main thing on this, we wanted to practice you on foiling complex fractions and then foiling with these radicals. So I'm going to stop my share and end this video. So y'all, good luck.